Welcome back to my fourth Box2D tutorial, and in this tutorial I'm going to cover some of the more interesting joins. So what joins does is basically join together different kind of bodies, more precisely only two bodies. So for example, there are one joint which is called revolute joint. I'm going to use that, which basically so here is one box and there is another box right here, and join these two bodies together in the way that you set a common point. So for example this point, and these two objects can rotate around this point like that, and similarly with this one. So these can rotate, and of course they can move as well, but they can only move together. So more precisely, the point on one object is the same distance always, or I don't know how to pronounce that. So they can only move that way if both are moving. So just think about your arm. For example, you have an upper arm and a lower arm, and of course you can move together. They can rotate in a around a common point. They can move as well, but there is no such thing as the upper arm, for example, moving this way, and the lower arm moving this way. Or if there is, that is a serious disorder, and you may have to visit the hospital. Right, so this is something called revolute joint. There are other kind of joints, and you can find all of the joints right here in the Box2D folder, Box2D Dynamics joints. As you can see, there are kind of few of them. Here is the revolute joint I have talked about, and there are other interesting is the wheel joint. This is the other one which I'm going to show you, but of course you can also try these other as well, but I'm not gonna cover those because the time is limited. There are not too many cool examples with all of them, and it's kind of same to create one joint to another joint, because you have to basically do the same steps for that. And I'm actually covering this by showing you an example, more precisely a chain bridge. You may have seen a chain bridge already, but if not, I can compile this program already. Okay, it turned out I cannot compile it because it's not on this computer. Anyway, so what I'm going to attempt to do is first have one static object, so it's one static box, then have another static box right here, and then from small segments like this with the revolute joint, I'm going to make a chain bridge between these two static objects, and it will be pretty cool looking. It can increase the realism of your game by much. So you can walk through this bridge, and of course it will seem like it will be from rope or chain or something. So it's more like a practical application for this, and I'm going to create a function which will going to create a bridge, and the name of this function will be create bridge. So void create bridge, and this create bridge will actually waiting for 4 parameters, the two bodies, so the two static boxes right here, so this static box right here and this other static box right here, of course the two objects between which we want to make a bridge. So this is of course a B2 body, and I just call it static 1 and another one, so oops, and I will just call it static 1 and another one, so B2 body, and I will call it static 2, and I will also ask the size of each of the bridge components. So I ask for the width of the bridge component, so width, and also the height of each of these bridge components. So let me just get it as an int w and int height. Perfect. Okay, so first of all we have to get the points between which we want to make the bridge. So we want to get this point from the bridge, from the first static object, and this point from the second static object. I want these in word coordinates to be easier to work with. So this is a little long line, but so first of all we have a vector which we are going to use as a storage for the coordinate. Obviously this will store this coordinate right here. To get this coordinate, first of all we have to get the word coordinate for this cube right here, the word coordinate, and then add the local coordinate of this, because the get vertex, which we are going to use to get the position, is returning with the local coordinate, meaning that from the center. So from the center it's, I don't know, 5 unit, 5 unit, but from the 0 0 coordinate, so from the word center, it's actually much different coordinate. So I will just call it position 1, and so first of all let's get the word position, so sta1, and I will get the word center from this, so right here. So I get the word center is this, so get word center. It was just as simple as that, and then I have to get the vertex, so this vertex right here, which is vertex 1, because the vertices are defined like coming from here. This is vertex 0, 1, 2, 3 with the set as box function. So I have to add the st1 and let me actually copy this. It will be easier because we have already typed this long line in once. So I have to get the sta1. So I get the fixture list, which is basically the shape. I will get the first shape from this, because the fixture list contains all of the different shapes. We only have one shape, so it doesn't really matter. So we get the shape, and finally we get the vertex 1, because vertex 1 is the right upper corner of the cube. Okay, so let's check the parentheses. I think we need more parentheses somewhere. Okay, and actually we have to convert it to pixels, so meter to pixels multiplied by this. Okay, let's check the parentheses. Okay, one more parenthesis, and we are finished with the first. And actually let me immediately get the second, which is basically the other cube's position, so position 2, and this will be the same except everything is sta2, because we want to use the static body 2, and also I get the vertex 0 because now I want the left top corner. Perfect. We have the 2 position. This was hard, but we made it through. Now we have to determine how many bridges or chains or whatever these small blocks are called do we need. How can we determine that? First of all, we get the distance between the two. We can easily get the distance between the two. Here we have the 2 variable, position 1 and position 2, and I just subtract them from each other to get the width between the two, and then I divide that by how many the width of each of the blocks to get how many blocks do we need. So let me create a variable int db, and this db will be equal to position2.x minus position1.x, and this is divided by w, which is how many which is the width of the blocks. Right, and then we can pretty much just welcome back, try out how revolute joint actually work, and actually most of the other joints as well. So let me open up the joint header file in the joint folder, so right here b2join.h, and this is the usual joint, so this is a base class and all of the joints are inherited from this class. We have a joint definition. This is similar to body definition. You can set a few things in here. Type, you don't want to set it manually. Every single joint, set it to your liking. And user data, you don't really need to set that unless you want to read it some callback function or something. But here is the 3 important stuff: the body A, the body B, and the collide connected. So the body A, as I said, there are 2 bodies in a joint, any kind of joint. Of course, you can join something to another body which already have a joint, and it seems like it has 3 joints in a row, but every joint actually have just only 2 bodies, so the body A and the body B. Here you just pretty much set the A and the B, so the 2 bodies. And also we have a boolean variable collide connected. If this is true, then the connected bodies will actually collide. Sometimes it is useful, sometimes it is not. It depends on the situation. So first of all, we have to create one of these b2 joints def structure, so an instance of this structure, and then set the specific parameters. So we have to set the body A and body B for sure, but also if we go to a specific joint like the revolute joint, we have other stuff which we can set. For example, here the local anchor A and B, which is pretty much the point, as I showed you, the common point according to which they can rotate. Okay, and there are also other stuff in here, like you can add motors to it, so it's like a motor. It helps it rotating. I will not do that in this video. I will do that with the wheel. Okay, you can also set limits, so it cannot rotate more than a specific angle. Again, think of your arm. In your lower arm, it can't rotate backward more than 0 degrees and forward more than 160 degrees about. So this is, you can set a limit right here, lower angle, upper angle, and enable limits. So this is logically can be set. Again, I will not do that in here, but I think you can do it manually. So the first thing first is we have to create this B2 revolute joint depth. So let me create one of those. B2 revolute joint depth. Of course, if you want to create another kind of joint like wheel joint, then you obviously create the wheel joint depth. This joint depth is actually in every single one of these joints. So and only this part is changing, of course, the name of the joint, but everything else remains the same. And of course, in the header file you can find all which you can set. As you can see, it sets the type manually from this B2 joint, so you don't have to worry about that. And you can set all of these variables, but actually, as you can see, some of that has actually all of that have default values, but we will only set what we will need to set. So first of all, let's add the name to it. So I call it joint depth. Right, and set, as I said, the body A and the body B. So right here, the body A, joint depth dot body A. This is one of the bodies. I will choose that this will be the static body, but of course it can be in a reverse order. In that case, the anchors will be in reverse order as well. So the body A is equal to the STA1, so one of the static body. And actually, let me create a square right here with this function, and not draw square, but create square, add rect. Okay, add rect with this function. So that will be our other. Go back. So let me create BT rigid body, and I will call it I don't know, for example, previous. And we need a current, because how I will build up this bridge is pretty much I will have one block right here. This will be our current block, and then I swap the order, so this will be the previous block. I add another block, this will be the current block, and that's way I will go. So always the thing which I am working with is the current block, and I will have a previous block, because obviously we need to store the previous as well, because the joints are between two bodies, the previous chain basically and the current chain. You will see it's more detailed whenever I'm coding. So I will create one with the previous. Now it doesn't really matter. I will just show off. I will just show it how to make one of that. I will not create the whole bridge yet. So the previous is equal to add rect, and of course we need the coordinate. The coordinate will be the position 1, which is, if you remember, the right top side of the first static object. This will be our x coordinate plus and I get the x, and I'm pretty sure I should add the width divided by 2 to it, because as you probably remember, the center point of the rectangle is the center, basically, not the top left side. And of course I should convert this to meters, so multiply by pixel to meters. Okay, the second is the y coordinate. This is just position 1.y. I will not care about the height in this case, and I just use p2m, so to convert it to meters. Okay, the next is the width and the height, and finally the dynamics. I'm pretty sure that should be true. Okay, and let me just create one of the joints between this static body and this body. So joint depth dot body B, and this body B will be the previous, which we have just created. Okay, and one last thing is remaining, is to set the two anchor points. So basically the point which according to which they will rotate. To set it, I will just use joint depth dot local anchor A. This will be one of the points, and I should use the set, shouldn't I? Yep, I should use the set dot set, and this needs two parameters, of course, the x and the y. So the local anchor A is the point in the body A. So I want to get the right side of the previous object and the left side of the current object, so right here, and this will be our common points, and of course they can rotate like this. So this is what I want to make. So here I should set the SDA, so the right side, and right here I should set the left side. This function actually waiting it in local space, as you can see, local, so not in birth space like we get here, the position. So let me actually copy where we get the vertex, this stuff right here. Okay, so right here I just get the vertex 1, and the vertex 1, as you have remembered, is in local space, and actually it's perfect. So we need this x coordinate and the 0 for the y coordinate. It doesn't really matter. I could get the vertex 2, actually I could get the height or divided by 2, but it doesn't really matter in this case, and we need more parentheses, I believe so. So let's open up one more. Yeah, that's okay. So what I have done here is basically get the left and the top right side of the static object, and this will be our common point, and right here on this other object we get the minus the width divided by 2, because we want the left top side of this other object. So let me get that. So join depth, and I call it local anchor d dot set, and right here I set the minus width divided by 2, because I have created this rectangle as it has width, and to go back to go back here we need the minus width divided by 2, because this is the width divided by 2, obviously. Okay, and of course one thing I almost forget is we should convert this to meters. We don't have to convert that, that's already a meter. We have to convert this, so multiply by meter to pixel to meter, and just set the other to 0. It doesn't really matter. And we are almost finished. One last thing is remaining, is to add the joints which we have created. To add the joints we don't need anything else, just use the function create joint in the word object, and it's only waiting for the address of this definition. So address of joint def, like that. Perfect. We don't need to create this as dynamic or something. It will make a copy for you, so nothing to worry about. And actually we are finished with the first chain. So right here, this is the first chain, this is the static object, and right, let's actually try this out if it is work or not. Right here in the, where should we do that? Right here, whatever. So I will call this create bridge function, and we need the 2 rigid body first, right? So let me create a B2 rect rigid B2 body. So let me create a B2 body, and I call it SDA1, and this will be add rect, and let me see, the x coordinate should be from 100, and the y coordinate is let's make it, actually we should convert it to meters, so pixel to meter. The y coordinate, let's see, somewhere down in the screen we have 480 space, so let's make it at 300. Okay, the width, let's make it 50, and the height, let's make it 10. Okay, and maybe it will work or not. And we need to create another one, and the only difference that this will be on 600, the rest of the stuff can remaining. Okay, and I call it SDA2. So SDA1, SDA2, and the width of each component, I don't know, make it 30, and the height is 10. Okay, so let's try this out. Alright, a few mistakes. First of all, we have to go here to the create bridge, and this is B2 body, because we are not in bullet physics yet. The rest of the mistakes are actually this get word center is with capital G, not lowercase g, and pretty much that's all. So if I compile it now, as you can see it's compiled, and if I run this right now, the static object should be static, I forget, so let's add a 4-second parameter to it, because as I said it's static. Okay, and now try it. It's way up high. Why is it that high? one thing is that the position 1.x is already in meters, just the width should be converted to pixels. Right here as well, the position is already in meters. So let's see. Alright, I forget that we convert the pixels to meters in the addrect function, so I don't need this multiply by pixel to meter variable. We just need to put the numbers right here, and now if I run it, as you can see, these two joints, as it should be, they are connected together. And yeah, this is it. We will create the bridge between these two components. So let's go back to the create bridge, and alright, so let's make the chain. One thing which I have noticed, although, that I have already converted this meter to pixel, so let me just delete this multiplication, which would try to not from so let me delete this multiplication, which will convert it again and screw up everything. So let me just delete that, and now it's okay. So this is pretty simple. Let me rename this num, like number, and we are going to use a for loop for each chain segment. So for int I equals 0, I less than the number of chain segments, I plus plus. And right here we almost do the same thing, so let me just copy and paste this right to here. Okay, and tabulator. Alright, so right here I just create a new current object. So let me again show you this little thing I made in GIMP right here. So this will be the current chain segment which we are currently working with, and we also store the last chain segment which we have worked with previously, so current and the previous, and we will create a joint between these two. So I create a new current object. One thing that I add the I times width to it, so each chain segment has a, so basically I add each chain segments to the width, so it will come one after another, so 1, 1, 1, and so on. So not create it all in one place and then make the joints take care of positioning it, although that may be work, but it's better in this way. So right here I just add the I plus the width, I times the width to it, and that's pretty much all the change. And why didn't I copy that line? This line. Okay, and what else we have to do? At the end, set the previous equals to the current, because in the next loop the current will be so the previous will be equal to the current, because the current will be equal to a new chain segment. And we have to change the local anchor A, because now we have the, why didn't I copy that line? This line right here. Okay, so the joint body A is equal to the previous, and body B equals to the current. Okay, and let me just delete whatever I wrote in here. Okay, so I need to get the previous the previous object's right side, so pixel to meter. So I get the width divided by 2, and the left side of the current object. And the left side of the current object, so I do minus width divided by 2, because the center, so the 0, 0 coordinate is the center of the rectangle. Alright, and finally I think we pretty much can try it right now. So let me just try to run this, and problem is at function 1, of course I forget the 0 at the second, so the y coordinate of the local space. And now as you can see, we already have a chain segment right here. It's a pretty cool chain segment. It would be a little better if we would move this SDA1 a little bit on the top. So let's move it to, I don't know, 10, and let's see what happens then. As you can see, we have a lovely chain segment right here. Okay, it's pretty realistic, but that's not exactly what we want to do. We want to connect this side to this other static object. By the way, one thing is that of course you can activate the collision with itself, so these things like this doesn't happen whenever the chain segments go into each other. So of course just set this collide connected to true and for every single segment, and it will be alright. Okay, so here where we are, so let me just set back to 300, and we need to do one last thing, is to connect the last, so this previous variable, to the new chain segment. And again we have to do pretty much the same thing as we have already done. delete this line. So set the body A equals to the previous, which is the last of the dynamic segment. Right here we set the current equal to the previous before we exited the loop, so this is the last chain segment. And here let's add the number times the number times width to it, because this is the last position which we are going to go. And also set the current body equal to the static body 2. And now we should get the right side of the previous, so width divided by 2 multiplied by pixel to meter. And also we have to get the left side of the last static body. To get the left side of the last static body, we have already did that right here, as you can see, just we did it in global space, or in word space more precisely, and we need it in local space. So let me just copy this second part right here, so the second part, and I just get the x component from it, and the second parameter is just 0. Alright, and that was pretty much it. I think if we all run this program at the moment, okay, let me just actually this is not needed at all. Alright, so let me run this program right now, and we will check if it's working or not. Okay, it's kind of working, although the number of components is a bit too many. Why are there so many components right here? Interesting question, I don't know. But as a simple solution, let's just set it -2, and it should solve the problem in the short term. Okay, you can see a bit less components, or just -1. Okay, actually I'm not really sure why there are so many components. Shouldn't be so many components. Anyway, this was it, so how you can create a chain bridge. And also I want to show you how you can use another joint, which is the car joint. We will take a look at that. But let's first take a look again how this program works. So first of all, we create two static objects. So right here I just create two static objects on the game. Right here one static object, and right here we created the other static object. Okay, right here in the function, which is the create bridge function, first of all we get the right position of the one of the object and the left position of the other object. Okay, and then calculate how many chain segments can we put between these 2 points. And then I will put the first segment manually. So I manually put the first segment right. Actually, I do it in this way. So I put the first chain segments right here to the right side of one object and the left side of this new object. Okay, right here this is what I do here, and I add a joint between them. So right here the rotation point is about here, so they can rotate around that point. This is static, so it's not rotating, so only this one can rotate. Then with a for loop I go through every single object. So I go to here, and then here I use always the I times width to make a little bit of space between each object, and I go until I have the number of objects. And in every case I add another joint between the two. So right here, 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 and here. Okay, so I add joints between the two, and then finally I add the last joint right here. This is after the for loop. I didn't add that in the for loop, it's out of the for loop. And that's pretty much what I do. And with this local anchor, I always just set the current anchor. So for example, here we need to get the width divided by 2, and from the other segment the minus width divided by 2 to get this point. And of course I have to do this with every chain segment. Right here with this static object I just have to get the vertex which is on the right, and here with this object I have to get the vertex which is on the left. The vertexes, whenever you use add rect function, are in the way that 0, 1, 2, 3. So they are going in this way. I will get the vertex 1 right here to get the right side, and the vertex 0 right here to get the left side. That's pretty much what I am doing right here in this function. It's pretty simple once you look it through. The joints are pretty much created always in this way. So first a joint definition depending on whatever joint you are using, and then set the body A and body B in every case, and depending on whatever joint you use, you set the stuff you want. So the local anchor, if there is, the motor, the limits, and so on. And finally, you call the create joint function, member function from the Word, and that is pretty much it, how you can create a joint, any kind of joints actually. So you just open up the joints, choose a joint which you would like, for example this pulley, and then set all of this stuff right here, and that's pretty much it. Okay, so I want to show you one more joint, which is the wheel joint. I hope I have time for that, and I will create a simple car with a wheel joint. So if I just open up the wheel joint right here, I can set all of these stuff. I will show you how you can enable motors as well right here. So enabling motor is pretty much adding a motor to the car. It can be used with the revolute joint as well, although adding a joint to a chain doesn't really make sense, but adding a motor to a car does. So let me actually just quickly make a function. So this will be a void function and make car. Okay, and let me actually wait. Actually, we don't really need parameters right here. Of course, you could wait the position and stuff like that. And also, I will add a global variable b2 wheel join, and I just call it wheel or whatever. Okay, because we need to add a. So we actually will add force to the car whenever I press a key, and I will access this key pressing in the main function, so I need the wheel joint. By the way, this create joint actually gives back a b2 joint, so this b2 joint pointer, and you have to cast it to a to whatever you are using. So for example, if in this case, if I would really interested in what joints do I use, although I'm not because I don't want to do anything with it, but if I would, then I will just create a b2 revolute joint pointer, and I will just call it, I don't know, joint, and this will be equal, and I have to cast it because this is a b2 joint, not a b2 revolute joint, which it will return a b2 revolute joint pointer, and like that. So in theory, I should be able to compile this right now, and indeed I can compile this right now. So if I would be interested in the joint itself, then I would use this, although I'm not interested in it. So of course you could enable the motor and stuff like that, but it doesn't really apply to revolute joint. Okay, but here in the car it is actually applied. So the wheel joint is pretty much what it sounds like. It creates a wheel for obviously a car of some kind. So what I will going to do is basically create a body of the car. So it will be just a simple rectangle for now. I will create two circles right here, one circle, another circle, so it will be a very simple car, and I apply motor to one of the wheel and do not apply motor to the other one. So it has only one wheel which actually have a motor on it, for example the back wheel or something. The other is just of course rotating as well, and here will be the center. So here I will just apply the local anchor. So if I go here, as you can see here, we have the local anchor as well. So what I'm going to do is one of the body will be the chassis of the car, the other will be the center of the object, so of the wheel. And similarly I add another one which is the other wheel, and that is it. This is just as simple as that. So right here I'm going to first of all let's add the chassis of the body. So b2 body, oops, that doesn't work out. So b2 body, and I just call it body because this will be the body of the car, and this will be just a simple square. So add square, and here we should tell where do we want to put that. I want to put it in the 200 position, so on the bridge, on the x-axis, because the bridge is from 100 to 600. On the y-axis I want to put it about 200 as well, so it is above the bridge. And the size, let's make it just 100 pixel by 40 pixel, and this will be a dynamic body, so I don't have to write anything as the last parameter. I also need to add two circles which will be the two wheel of the car. So I will call the function add circle x, y and r coordinate. So let me just call that 2 times. So b2 body, and this will be wheel 1, and add circle. So x coordinate is about 200, so the 100 is the width of the car, I don't know, 150, and make the y coordinate equal to I don't know, 170 or something, and radius, make it 50. Okay, and let me just copy and paste this right here. This will be the wheel 2, and the only difference that this is 250, so on the two sides of the car, so this point and this point. I hope so, maybe not, we will see. Actually, an easy way to check this is to set this to false, so static body, and check where are these wheels and chassis and car body. So if I run this right now and type it right, so this is add rect, not add square, so add rect, and now I can compile it, and oops, that's not it, and run it, and I don't see the car. Why I don't see the car? I don't see the car because I don't call this function. So let me just call this function right here under the create bridge. Okay, and now if I run the program, as you can see, we have the car right there. Although this is kind of wrong, because we should increase it with 30, not decrease it. So this is 230, the y coordinate, because this is not like in OpenGL, but this is like in SDL. So it starts from the what? Let's see if it is solve it. Yeah, it's kind of solve it. So this will be our simple car. It's a pretty simple car. Okay, but these are all static, so these will be dynamic later on. And this was just a quick test to test this out, so if it is work or not. Next thing on the list is to add the wheel to the car. So to do that, I will create a b2 wheel join function, bJoin def, so a class, not a function, def, and I will call it joint def. Okay, and here I have to set a few things. Of course, the body A and body B are the two things which we always set. So joint def dot body A, and the body A will be equals to the body of the car, and the joint def dot body B, the body B will be equals to wheel 1. Right, and the wheel 1 will have the motor. Let's first set the local anchors. So joint def dot local anchor A. So the local anchor A is the anchor on the body, which will be minus 50, I guess. So minus 50 times pixel to meter, so the half of the width of the car, because we are going from the center. The y, actually this is the x, the y coordinate is actually minus 20, I guess. So minus 20, and here I should set it to 20. Multiply by pixel to meter. So basically I'm going to the bottom of the car. So right here the GIMP is, I just choose this point right here. Okay, and then the B is just 0, 0. So here 0, 0, because we want it to be centered, and the center of a circle is the 0, 0 coordinate. Alright, nothing new in here, but now the new stuff comes. We enable the motor. The motor will pretty much make the car moving. So joint def dot enable motor, and just make it true, so make it rotate. Okay, and I will also set the max motor torque. This is basically the maximum force of the motor. So let's just set it to about 100 or something. So we will test this out, what is a good number. I will just set it to 100, and we will see. So max motor torque, and so set it to about 100. Okay, the next thing is the current motor speed, and the current motor speed is okay at 0, because whenever we create the car, we will not have any motor speed at the moment. Later on we will add whenever we press a key. Okay, there are also this frequency, I'm not quite sure what is this, and this damping ratio is, I think this is something to do with the suspension, maybe. I don't know, we can test that out later on, but for now I'm pretty sure we are done with one of the wheels. So let's add the other wheel. So joint, of course we should add this to the word, right? So add this to the word, create joint, and we create the joint address of joint def. Okay, and as I said, we have to store the return value in this variable right here, in this pointer. So make the wheel equal to the b2 wheel joint, and we have to cast this b2 wheel joint, and yeah, b2 wheel joint, and this is word. Just the Control S doesn't work properly. Okay, so we will need to store this wheel because later on we may want to add force to it, and to add force to it right here we can get here and get the B2 wheel, actually right here, the B2 wheel, and then use the function which is set motor speed right here. This is the function which we are going to use. But for now we just store this in a variable. Okay, the second thing is pretty much the same, so let me actually just copy this stuff to save a little bit of time. The only thing is changing is that this is the wheel 2, and I set the wheel 2 position like that, and I'm pretty sure this should be positive 20, not negative 20. Negative 20 is again in the top of the car, so positive is the right number. Alright, and we are not enabling the motor right here, so we can just set it to false, and in this case this motor torque is not playing at all, and we don't actually have to store this right here. So pretty sure that was the only change we needed to done. And I think we have a working car. So let's go back here, and whenever I'm pressing one of the keys, right, let's make a uint 8 array and keys and make this equal to the SDL get key state. Okay, and if you remember, this get key state will get an array of keys about the all pressed keys basically. So if the keys, and I get the SDLK D is pressed, so if the D is pressed, then I just move the car on the left, so make the wheel and set motor speed with the capital S at the beginning, and set it, I have no idea what's a good value, so just set it to 100, and if it is too much then we will change it. Okay, and if the keys SDLK A is pressed, then just move it on the opposite side, so -100. Okay, and then let's try to compile it. 169 right here is the problem. What is the problem? Of course I should use the .set function because this is a vector, and the operator parentheses are not overloaded, so I just use the .set, and this should solve it. Okay, and it's compiled indeed. Okay, we have a slight little problem with the wheels. What is the problem with the wheels? Of course I forget to write this as B, local anchor B.set. Now if I run this, we have a working car. So let me just press the A or the D. Okay, right. Okay, it's kind of working. One problem though is that it's very slippy. So we should go here where we have this add circle function right here, and just set the friction. So fixture depth dot fixture, I'm pretty sure this is it, and set it to 0.01. I'm not sure if the bigger number is the less okay, so this was capital D. So set this friction, not fixture. What word is that? It's not even a word. Okay, so friction. So try to run it now, and okay, it's definitely worse. So let's increase this variable rather, so 0.8, and let's see what happens then. Okay, A. Okay, we should probably decrease the speed of the motor. So let me just come here and just decrease it to 10 and -10 to see what happens then. Okay, so A. Alright, this is a lovely car. It's working. Okay, so let's just check out this variable, which I do not know what is this damping ratio. So right here, just come here wherever I created and add this damping ratio. So joint definition dot damping ratio, and set it to make it 0.99, so almost 1, and let's see what happens then. Okay, I see it's not damping that well. And if I set it to 0.1 for example, then it will be damping very well. Yeah, it's kind of working, I guess. So that was it. I'm still not quite sure why are there so much spaces between these blocks. Let's call this function create bridge with a lower number, 10 for example, and let's see what happens then. Oh, that was unexpected. Let's call it with a higher number, like 50. I guess it's better. I'm not quite sure what's the deal with these big numbers, small numbers. So why are they more tight? I don't know. Okay, so let's just set this to 50. I want to write 50. Okay, so this was how to use two of the joins. So this is two simple joins, and of course according to this you can use other kind of joins, and I'm pretty sure we are probably finished with Box2D. It is not that complicated library. Of course I haven't covered several topics like the rest of the joins for example, and also I haven't covered collision filtering for example, and I haven't made a concrete example program, although I like to make example programs about every library which I do. So I will probably do an example program later on. So thank you for watching and have